Buenos días a todos y bienvenidos al evento final.
Good morning, everybody, and welcome to this last event of the HYPOBRICK project. I am responsible for the project area of the Institute of Ceramics in Castellón. And before starting this opening event, I want to thank the European Commission for letting us use this space for the event. I want to say thank you also to the speakers because they are going to transmit their feelings in this important sector, which is the ceramics sector. And also I want to say thank you to the public who is here on site and the people who are online. Some important things to bear in mind: the restrooms are to the left if you need to use them. We have also simultaneous translation. Channel number 1 is Spanish, channel number 2 is in English. And also on the desk at the right you have the project, the papers of the project that you can take to revise it. Without further ado, Maciek Minesecki, he's going to speak. Thank you so much. Good morning to you all. I am Maciej Minesecki. I am responsible of policy and press in the representation of the European Commission here in Madrid. Same time, I am responsible of the Green Deal, European Green Deal on the European Commission. And it's my pleasure to open this event as part of the representing board. I want to welcome all of the organizations that support the Live HYPOBRICK project. And to the other participants of the event, it's not necessary to underline how necessary it is from the environment standpoint of the European Union to search for industrial solutions that can make the European Union to be more neutral, energetic neutral, which is what the Green Deal is about. And I want to congratulate Live HYPOBRICK and their owners and for the technology of creating ceramics and roof tiles, because it reaches to the goals of the European Union, like recycling of waste, building waste, and also enhancing circular economy and reduction of the gas emissions, of greenhouse emissions, and etc. A month ago, the European Commission adopted the industrial plan of the Green Deal with a main objective of easing the transition and financing of technologies of the intensive use towards a zero-emission industry. So the HYPOBRICK project fits pretty well in this industrial plan of the European Commission. HYPOBRICK also has this promising technology, not only for the environmental standpoint, but also from the commerce and business standpoint. So with this brief introduction, I want to wish all the best in the promotion of this technology and its development, and also a lot of success in today's event. Welcome you all, and thank you so much. Thank you, Maciek. Now we are having with us a second speaker. We have Christoph Wojcik. He is the project advisor of our LIFE project, and he's going to say some words.
Ladies and gentlemen, I'm terribly sorry, but my Spanish is not good enough even to say one sentence except of buenos dias. Maybe next year I'll be better and I'll try to speak to you in Spanish, but for now I think it's a safer way to stay in English. So I'm Chris Wojcik and I represent the CINEA, that's the Climate, Infrastructure Environment Executive Agency of the European Commission. We are responsible for implementation of LIFE, one of the very much unique tools that we've got to support the Green Deal that Maciek already mentioned. So I'm very much happy that today we'll have a great opportunity to discuss not only the HYPOBRICK project, but also some climate challenges that we all have now and we need to deal with them as soon as possible and as much as we can. So I'm I'm very much happy to be here today and to deliver you the presentation in a minute. Thank you.
Thank you very much, Christoph. We also had Nuria Matarredonda, General Director of Urban Agenda and Architecture of the Mobility, Urban Agenda and Transport Ministry, but last minute news, she said she cannot be here with us, and she's sorry for that. So we will start with the conferences. The first one is with Christoph, and he's going to speak about the best practices and new opportunities of the project LIFE. Christoph, the floor is yours.
Is it working fine? Okay. So today I'll try to guide you very, very quickly because I was told by the organizers I've got 15 minutes and 0 seconds. So I'll try to be very much dynamic on that. I'll try to guide you through the life, what we can offer you, what you can offer us within the projects and within the packages that we've got in life. But before I'll start, I just want to underline one very much important thing, which is very much aligned with our today discussion, and which is the climate change, the climate crisis. I want to mention the terrible fire that is devastating the Castellón area at the moment and the other areas in Spain. This is terrible, terrible thing, and I know that almost 2,000 people were evacuated so far. I know that some of you people present today in the room have their very close relatives over there, so I feel sorry for you and for the troubles. I hope that the fire will be destroyed very soon. Just to mention what your Prime Minister, Spanish Prime Minister Pedro Sanchez said on Monday, this is very much an evidence of the climate crisis we've got and the challenges we've got. And from now on, he said the climate change mitigation policies should be the priority not only for the Spain, but for the Europe and the whole world. So let's go straight to the business, how we can support that fight that we've got in our hands ahead of us and then the next generation within the help of the LIFE. As Maciek already mentioned, we have a great package of Green Deal in our hands, so it's a great, powerful tool in Europe that we've got to counterfight the crisis that we are facing at the moment. As you all know, 1/3 of the whole European budget will support that fight. I will not mention all of the ingredients that we've got in that menu for the Green Deal. Just to underline one, the LIFE program, our Today Hero, a very much unique tool to support the very good projects and to support our fight. So the LIFE was born in '92. It's already the 6th edition of that unique program. We already supported over 5,000 projects. This is enormous number of very good projects, the best in Europe, the best in the world, to support our challenges. We already supported almost 30,000 of beneficiaries, and we are still evaluating the new proposal. We still have the new calls in our hands. I'll just tell about that a bit later. Just to mention the value of those projects that we already supported, it's almost 12 billion euros, and the contribution, EU contribution for those projects is over 5 billion euros so far. About the LIFE itself, the LIFE puzzle we've got, currently, the LIFE is divided into 4 subsectors: the nature and biodiversity, circular economy and the quality of life, the clean energy transformation, and the climate change mitigation and adaptation. I'll try to deliver you some examples for each of them. I'll try to guide you what is inside of all of those 4 packages. So the first one is the nature and biodiversity. These are, in short, the conservation projects, in particular in the area of the biodiversity, habitats, and species. To give you the first example, this is actually the package of the projects that we supported in Belgium, in Wallonie region from 2003 to 2020. It was called the peat box, and it was about the restoration of bogs, mires, and heathland habitats. Just to give you the assessment, the objective assessment of those projects according to the national report on the nature from the Belgian authorities, these were one of the most important projects in that area in Belgium, with a very, very much positive impact on the nature in the Wallonie. The next one is CEQL. This is circular economy and the quality of life. And this is about the transition towards a sustainable, toxic-free, circular, energy-efficient, and climate resilience economy. So in short, this is about recovery of resources from the waste, air, noise, soil, chemical management, as well as environmental governance. On the diagram in the middle, you can see the biggest number of the projects we are supported in the subsectors, in the industrial sectors or in the market sectors. The first one is the agriculture and forestry, and this is being followed by the food, beverage, and constructions and building sectors. But as you can see, the variety of the sectors that we can actually support in that is very, very big. So please go ahead and bring your projects to that sector as well. To give you the example about CEQL projects, what do we have in mind? This is a great Latvian project, Fit for REACH. As you can see by the name, this is about to support the REACH regulation about the registration, evaluation, authorization, and restriction of the use of the chemicals in the European Union. So the project was about to prevent flow of the hazardous substances into the Baltic Sea region by preventing them at the source. That means at the level of the companies, at the level of the SMEs. The projects supported the companies in finding the alternatives, more eco-friendly alternatives for those substances by redesigning the mixtures, but a new approach to those substances and to fit into the REACH regulation. The project produced great tools for SMEs, how to find the alternatives in the subsectors. So please very much feel welcome to pass the message to your SMEs in Spain as well, to use those tools, because one of the biggest achievement of the life is like we are not having the same projects twice. It's about to have the project and then use the results by all of the others on the market. So not to reinvent the wheel 2 times. It's not necessary, it's time consuming, no one wants it. So it's about to use the experience from each and every project by the others to have the better the projects in the future. The next puzzle from the life is the clean energy transition. This is about building a national, regional, and local policy framework for the clean energy transformation, technology rollout, digitalization, business models, new services, attracting private investments for the clean energy, and involving and empowering the citizens for the clean energy. Very quickly, to give you the example, GeoBoost. This is very nice projects about boosting geothermal heat pumps via developing business models, preparation of the regulatory framework, are very much important, the tools and the trainings, not only for the operators, but also for the consumers, how to use it in the most efficient way, how to approach that exercise, how to better use the heat pumps. Now the fourth one, my favorite one, maybe because I'm working in that sector especially, so this is the climate change mitigation and adaptation. This is of course about the shift toward a sustainable, energy efficient, renewable energy based and climate neutral and resilience economy. You see 2 parts, I'm going straight to them. This is about CCM's climate change mitigation. In short, this is about to prevent or reduce the emissions. These are the projects that are targeting exactly that challenge. CCA, climate change adaptation, it's about to, through the projects, help to cope with the changes that we've got already on the market, with the dries, with the extreme weather conditions, and so on. And the governance, it's about the governance and information and awareness rising. Into the details now, straight away. The CCM, climate change mitigation, is about to reduce greenhouse gas emissions in the sectors which are not covered by ETS, EU emission trading system. This is about the functioning of ETS and the impact on energy and the emissions, generation and the use of renewable energy and improvement of energy efficiency, and the land and management practices. In short, one again, it's about farming, the project's about farming, land use, peatland management, renewable energies, fuels, new fuels, green transport, conservation of the natural carbon sinks. We also support, maybe it will be interesting for you as well, integrated strategic approach. That means the projects about implement of climate change mitigation strategies on the regional and the national level. I couldn't pick any other better example in the CCM than our today's hero, the live HYPOBRICK. Of course, this is about the manufacturing bricks from the waste. I'll not tell more because we'll have the next presentation about that, so I don't want to steal the information from our today hosts. Adaptation, the second subsector of my portfolio. This is about urban adaptation, land use planning, resilience of the infrastructure, weather conditions, resilience of the agriculture, and again, integrated approach, integrated projects that support the implementation of adaptation strategies on the regional and national level. The very good example of that is the project Life AirFit, which demonstrates the innovative technique to prevent the damage from pluvial flooding in the cities and the companies. This is very much important, especially for the cities and the companies that separate the flooding, the rainwater from the sewers. So this is about the very special technique, which is called the fast high volume infiltration, the technique that uses the infiltration wells to infiltrate the water straight to the aquifers. About the climate governance and information, the last subsector, this is about the public and stakeholder supports, rightness of the awareness, providing training, dissemination of the best practices. We've got very, very good projects within that area, and I would like to say that we would like to have more Spanish projects in that area as well, because it seems like the Spanish applicants are more interested in the other subsectors, but in here it's always quite nice occasion to do something very, very good. To give you the example, I'm almost finishing. I have 4 minutes, yep. This is the project Regenerate Life, done by the Bankwatch in the Eastern and the Central Europe. This is about supporting those countries in their trips towards the zero-emission economy and just transformation. As you know, some of those countries still have the coal. I'm the Pole myself. This is the best example, maybe not the best, maybe the worst. It depends on the words and the point of view. But this is the example of the country that still base its economy on coal. 77% of the Polish economy is still based on coal, and this is a huge challenge we've got in our hands in front of us, not only for Poland, but also for the other countries. So the main activities within that project were the building just transition platform, knowledge base of energy, and last but not least, about very, very important aspect that we forgot about that, and we treat it as one of the soft activities. That means the rise of the awareness of the stakeholders, of the regional, of national, of local stakeholders, authorities, about how important it is to support via the permits, via the regulatory, via the policy, implemented on the local and the regional and national level to support that fight and to fight the climate crisis. In short, it's about how to use the money now, how to use them in the best possible and effective way, and not to wait for the future and to avoid the situation you see on the picture. We don't have any more time to lose. We need to act now, and we cannot wait for something in the future. Let's do something in 2 years. No, we don't have 2 years. Now, the example that I mentioned at the start of the meeting about the Castellón and the other region, Teruel? Yes, sorry, it's difficult to pronounce for me. Yeah, it's the best example. We cannot wait. We cannot wait. We've got the money. We've got European money. You've got your money. There's about the willingness to act now and act really, really hard to prevent the further damages. Almost the last slide. This is the live calls that awaits you and your applicants in this year within the live. As you can see, most of them will be started in April. You will have few months, your applicants will have few months to deliver the best application until the September. The clean energy transformation will be launched a bit later on May, and you will have a bit of more time. And the last slide, 14 minutes and 30 seconds. At the moment, I just want to ask you for one favor. And it's not the favor for me, it's the favor for all of you, for all of your children, relatives, and all of the generation. Use your private and professional contacts. Very, very often it's about the information. This is the key thing in the whole exercise, about the information. If the applicants, if the good companies, if the good bodies in Spain, do they know about the life? Maybe not. That means that we are missing the opportunity to support them. Why? I think it's, if you can, just use your networks to spread the news about the life. Look, this is a very good funding opportunity for you. If you've got the bright idea, come and bring your application. Our today host know very good about that, how it's possible. The competition is very high, fine? It's very high. It's not so easy to be funded. We've got lots of best projects in Europe, and it's difficult to go through. But it's worth trying. Okay, sometimes you can find the different sources of the money in different parts of your environment. That can be national, regional. But actually, what you saw already on the slides is very much unique. No other program is able to support exactly those programs, as I mentioned, exactly those sectors, exactly those activities. So LIFE is a very good exercise for you, and it's good for the environment, for us, and for the future. So please help us, please help yourself, and let's do it together. Thank you.
Thank you, Laud. Christos, no tenemos prevista turno de preguntas.
Christoph, we are not having Q&A now because we are pretty on time. So at the end, if we have spare time, we will have a Q&A session. Now we are going to move on to the following speaker, which is Ana Mezquita. She works in the Institute of Ceramic Technology, and she's going to speak about the European context and requirements in Europe in energy policies.
Disculpad. Voy a empezar haciendo un repaso.
I'll start reviewing why is it so important for us to collaborate together in this mission to reduce emissions. If the slides work, that is. There you go. Okay, these are the emissions and their evolution worldwide since 1990, okay? So we can see how in the last 3 decades, worldwide emissions increased very significantly, up to almost 38 gigatons of CO2. Here you can see the different events that happened through time and how there was a decrease in emissions due to COVID. However, the increase is continuous, and we can see that there's no stop to it. What's Europe's role in all of this increase? Here we can see how different areas in the world have contributed to all of this. Throughout this, India has been collaborating quite a bit, and developing countries, India and China, are those that have most increased their emissions. However, the United States and even Europe have been adopting policies to reduce these emissions. This means that for 2022, we have 2.8 gigatons of CO2. What does this mean? That out of 37, 7.5% belongs to us. That is, Europe is responsible for 7.5% of total emissions worldwide. What have we done internationally to reduce all the emissions? CO2 emissions here. CO2 is one of the greenhouse emissions that causes global warming. In this graph, you can perfectly see how at the turn of the 20th century, the planet's temperature hovered around, well, hadn't really gone above, even reduced a little bit, but from the 60s and 80s, it increased continuously up until the current day, in which the average warming of the planet is Celsius degree above the industrial era. To try and mitigate this effect internationally, we thought about adopting rules and regulations, laws, in which all countries could contribute to help curb emissions. The first protocol that was adopted was the Kyoto Protocol, which is well known by all in 1992. The document was drawn up, and we established and set conditions to adopt it. It was signed in 97 by 84 countries, and it came into force. The greenhouse emissions are not only composed of CO2, hydrofluorocarbon, and several other toxic gases, such as methane and nitrous oxide. All of this is very hard to control, and CO2 is the main culprit, so we wanted to truly curb those emissions in particular. We have reviewed the protocol, and some other countries have been added. Between 2008-20 and 2012, we had the first period, and then from 2013 to 2020, the second period of Kyoto Protocol included the Doha Amendment. In 2020, and internationally, our politicians thought, how must we go on? We must gather all of the efforts, international efforts, under one document, which is how we reached the Paris Agreement in 2020. The average temperature should not go beyond 1.5 degrees Celsius over the value that it had before the industrial era, or maximum 2 degrees, but our goal would be to be under 1.5 degrees. It entered into force in 2016, signed by 194 states, which represent 98% of emissions. Within all of this international landscape, what has the EU done? The EU has decided to be a flagship against climate change. No matter which country signed all the different international agreements and the Kyoto Protocol, it decided to spring into action and try to start rules and regulations to curb emissions. A first goal was reached, which is reduce 8% of GHG emissions by 2012 with regard to those in 1990, goal that they reached. The second goal was to reduce them by 20% in 2020, and we have reached this goal as well. We even went beyond it with 32%. The next goal within the framework of the Paris Agreements was to reduce emissions of greenhouse gases in 40% towards 2030, or by 2030. How have we worked on this? The EU has started to adopt rules and regulations. The flagship rule is the European Trading System that entered into force in 2005-2007. It has become a very efficient instrument to curb emissions, especially in some industrial sectors, and mainly industrial sectors that generated power. And little by little, some other sectors have contributed. First, it was only power generating and electricity generating industries, but then new sectors were added on, and also new greenhouse gases. They started with CO2, with mitigation and reduction measures, but with the years, other gases have been included, such as methane, that also produces greenhouse gases. We must say that the emissions trade affects about 40% of the total European emissions. There are other sectors, diffuse sectors, that also contribute in the 60% left. So the EU not only was working against greenhouse gases or was struggling against this through this to this European trading system, but there were also new initiatives in mobility, for instance, or friendlier fuels, boosting renewable energies, etc., etc. This is how we have reached all of these goals to reduce emissions that I was mentioning previously. Here we can see the evolution of CO2 emissions in the EU, and we see how we were below the goals that were reached. What is the next goal? Reducing emissions in 55% by 2030. As we saw that our adopted policies were efficient and all of our goals were reached, and seeing the absolute emergency to fight against climate change, our goal has become more ambitious. Instead of reaching 40%, we want to increase the goal up to 55%. And this goal is fostered by the European Green Deal in Europe, which creates a roadmap to reach this goal. So how do we establish the actions to reach this goal? Through the European Climate Law and throughout all the legislative regulations derived from this European Climate Law called Fit for 55. So all of the laws, rules, and regulations that have as a goal reaching 55% in GHG emission reduction. We want to be the first neutral continent in emissions. Let's have a look at these actions and these package measures. You can see all of these actions here. We want to boost renewable energies, energy efficiency, energy taxation, etc., etc. Well, here we were with all of these goals and struggles and fights, pressure from all sides to try to decarbonize the economy. And then suddenly a war burst in Ukraine, and it created an energy crisis in Europe since a significant part of gases consumed in Europe came from Russia. The only thing it did was to increase these goals and actions. Europe published the REPower EU program based on 3 pillars that can be summed up by: we need to accelerate clean energy transition, save energy, and diversify energy sources. We must reduce our dependency on fossil fuels, while trying to respect sustainability, favor and boost investment, and helping companies through this transition, not forgetting to maintain competition in Europe, because the risk of pressuring the economy for it to be decarbonized can cause its costs to increase and provoke a drain of companies toward other continents. So it's very, very important to keep economic activity going in Europe. Within all this European context, we must talk about the ceramic industry because it is energy intensive. It has been affected by ETS rules. It receives a part of the emissions gratuitously because it is one of the sectors that has a risk of carbon drain, but it is extremely committed in energy reduction and emissions reduction for a long time. A few years ago, in our roadmap, we were inviting the companies and industrial companies to reduce their emissions. And back then, the Association of Ceramic Industries published the first roadmap in 2011 towards decarbonization. In 2021, we have updated this roadmap to also update and adapt the sector to all these new worldwide goals to reduce our emissions in 55%. I have to say that the sector has been affected by this regulation. Under all the facilities here, the ceramic industry represents 10% of all industries affected, but it represents only 1% of all emissions covered by this regulation. This roadmap of the ceramic industry insists that the ceramic industry and all tiles, bricks, refractory bricks, and etc., all these sectors have worked hard to curb emissions in the last few years, and so we had worked already in this topic. The best available technology are already practically embedded and widespread in all companies. We have reached value in emissions that would be hard to reduce even more without significantly changing the technologies used in the process. What is the path here in this roadmap? Here we have conducted a simulation of emissions reduction to reduce emissions up until 2050 so that we can reach the net zero. It does not mean that emissions won't exist. It means that the emissions that exist that are unavoidable would be offset with one of the compensation mechanisms. This model wants to comply with our 55% goal reduction by 2030, and it is based mainly in reducing fossil fuels here, or combustion, and in the processes. With which measures? Many of these measures are similar to other manufacturing industries. So reducing combustion or additives containing carbon. This model will use renewable energies. We will go from fossil fuels to renewable energies, photovoltaic energy whenever possible, and also implementing biogas, biomass, biomethane, and syngas as well. Even though the quantity of energy that is consumed in ceramics is very high. So we will have a limited amount of renewable energies to use. We must work in other scopes as well, due to green hydrogen, electrification, and keep on working in reducing total consumption. So efficiency measures, improving insulating measures as well. So more traditional measures that still have value. They are still up to date because new kilns are going to be launched, new coating measures, etc. And concerning the process emissions, we want to reduce additives that contain carbon and try to minimize the raw material quantities. We have worked with Life HYPOBRICK in all of these goals. This new product can reduce emissions in the processing process and so it is totally in line with the roadmap embedded by the ceramic European sector, and it helps toward decarbonization. This is what I wanted to say. If you have any doubts, then you can ask questions at the end. Thank you very much.
Muchas gracias, Ana.
Thank you very much, Ana. The next talk comes from Mr. Antonio Mateos Alenda, who is the Energy Director of the Spanish Association of Brick and Roof Tile Producers. He will be speaking about the ceramic industry and brick industry in Spain facing our main and significant challenges of decarbonization. Thank you.
Buenos días a todos.
Good morning. I'm going to do a brief presentation on the sector of bricks and roof tiles in Spain, and to not dig much deeper, it's a sector that produces more than 6 million tons per year. This sector today has more than 130 companies that manufacture. From 2014 to 2021, we had previously 600, and now we have 130. So there's been a transformation or concentration of companies. So now we're having less. Each of the enterprises has a production of 50,000 tons per year. The business volume of this sector, it's around 615 million euros and has more than 4,000 people employed. A general view of the consumption related to emissions and production, we see that in year 2021, the production, as we see, it's around 603,000 tons. We don't have 2022 data because we are still gathering every number from the previous year, but I can tell that year 2022, it's pretty similar to 2021 because, as Alicia said, the impact of crisis, the energetic crisis, provoked a reduction of emissions, especially in the first semester of the year. As you see in year 2021, the emissions of the whole sector have been of 1 million tons per year. What Alicia said, that we are the 10% of the installations and 1% of the emissions of the whole Spanish industry, is not 1%, it's 0.65, which is less than 1. The energetic consumption of the sector, we have differentiated it by electric energy and also different fuels. So the electric one has a consumption of 431 per year, and the different biomass and fossil fuel, we have 3,700 per year. It is a quite heat-intensive sector with a consumption which is 10 times over in the thermal energy over the electricity consumption. As Alicia said, we are a sector under this glass of the emission trading directive, and the brick and tile sector accounts for 10% of the total number of installations, and our emissions only represent a 0.65%. Only a few weeks ago, we are facing a new challenge. This 55%, which is an average, we have a 62% we have to face. So we're moving from this 43 to a 62% in the year 2030. That's going to hinder a lot what we were mentioning before, the competitiveness of our companies, because this challenge is going to be very difficult to overcome. The ceramic sector has three main points of emissions. One is the process emissions, which are related to the raw materials. They come from the calcium carbonates, and it's around 25% of the emissions. These emissions are very difficult to reduce because it's the raw material, it's the carbonate that it's transformed into CO2. It is intrinsic. So the only way to reduce this is through raw materials which have less amounts. But these raw materials we have are not pretty close to the industry, and sometimes we have to move to farther places, and then the indirect emissions for bringing these raw materials have a bigger impact than using the materials we have here. The other one is the cogeneration emissions, which is mostly half of the sector has cogenerating installations which produce high efficiency cogeneration. That's especially when creating heat supply part of the energy needed in the process. And the main one, which represents a 65% of the sector's CO2 emissions, are the one that comes from the combustion emissions, which is necessary. For example, this is given for the fossil fuels, mainly in the kiln, where high temperatures are reached. In this process of drying, we can see the evolution from 2005 to 2021 on emissions. We see the emissions in 2005 in this process was around 1.78 million tons, and in 2021 we are in 0.3 million, so it's been reduced in an 83%. The combustion emissions have moved from 3.53 million to 0.68 million, so there's been a reduction of an 80%. And the cogeneration emissions, we're moving from 0.58 million to 0.1 million, so the reduction has been of an 82%. Another point to highlight of the sector effort is the emission intensity. We have moved from this 209 kilo per ton CO2 per ton of product to 171.32. So the intensity of the emissions in the production has reduced in nearly 20%. If we put it this, and we see it in this slide, we are moving from 5.9 million to 1 million. We are doing what we have to do. Sometimes they make us do it. This is our homework, and they force us to do it. And the emission reduction measures adopted by the sector are mainly the improvement of the efficiency of the equipment, the kilns, the dryers, reducing the consumption intensity in a 10% compared to 2005 and by more than a 20% compared to 1990. The specific consumption, the average specific consumption, because the sector produces several products, so it's not the same to talk about the specific consumption of a clinker brick compared to a coating brick, for example. So the average consumption, it's of 605 kilowatts per ton, has reduced to 541 kilowatts per ton. Another measure is the use of biomass. The use of biomass has increased, especially for the drying processes. This means there's been a reduction in the year 2021 of around 66 sorry, 6% of the emissions of this sector. The problem of biomass is the availability. It's not always available where the industries are. Sometimes the emissions of carrying this biomass from where it is produced to where it is consumed, it's bigger to the ones that we are avoiding. Another measure taken by the sector is the use of cogeneration plants, high-efficiency cogeneration plants. As we know, producing the thermal energy and electric energy at the same time from a cogeneration installation means a reduction of primary energy, which means there's a reduction in CO2 emissions. This measure now it's a little bit more difficult to carry out with the lack of support from the administration we are suffering. This is something that we should enhance and we should transmit or continue transmitting this information to the administration. This measure, which is available and it is already being deployed, should be more used. Another measure adopted is the installation of photovoltaic plants. A big part of the industries has used their roofs or their nearby areas and they have installed photovoltaic plants to be able to use this energy. We know this measure, it doesn't have a high impact because the electric energy they can supply with this photovoltaic installations doesn't reach 20% of the total consumption of their electricity, but there is a will there and it also helps to reducing the indirect emissions that they are having just for the use of electricity. This reduction of indirect emissions, it's around 6.5%. There are some installations that adopted some measures already 10 years ago, like in the case of Piera, which uses 90% of biogas from a landfill from a few kilometers away as their fuel for the firing and drying process. Not all of the industries are close to a landfill, so this measure it's quite scarce, but when the sector had the possibility, they have adopted it. Other measures we are analyzing, it's the use of hydrogen. Everybody now is saying that hydrogen it's the future for substituting gas in the future. And as we are having some gas supply problems, now more due to war, we have leveraged the situation to put some pressure through this lever of climate change and pressure for this change of fuel. We have been speaking more about how good this fuel is before even trying it or saying if it is viable to use it. It is basically non-viable to do a local hydrogen installation for each of the industries because economically it's impossible. That company would lose their competitiveness. They would be completely out of the markets. It will be like 3 or 4 times more expensive to use this fuel than any other fuel. There are many obstacles for it to be economically viable, and we are just watching. We are also analyzing the use of the hydrothermal systems for the process of the drying processes, because they already exist, these heat pumps with high COP, which already high temperatures between 90 and 100 degrees. So it can be an interesting alternative to use it instead of the fuel in the drying process. There's also an obstacle here, which is the bigger use of electric energy and the interconnecting points of the plants. And we are also developing and analyzing different biomass alternatives for the firing stage. And as we said, it is a fuel which is not stable or safe because the availability is not always the one we need for the industrial process. Thank you so much for everything.
Pues Antonio, muchas gracias por esta presentación.
Antonio, thank you so much for this presentation. Sometimes it is difficult to see this data in such a clear way. We really thank you for this. Now we are going from industry to the academic world. The following speaker is María Criado. She comes from the Eduardo Torroja Institute for Construction Sciences, the CSIC. And she's going to be speaking about the new technology and the live HYPOBRICK of the alkaline activation technology to avoid the activation of bricks.
Bueno, en primer lugar me gustaría...
Firstly, I would like to thank our colleagues, Dr. Javier and Dr. Monica, for having invited me to participate in this final event of the Live HYPOBRICK project. It is a true honor to be here. I'm going to try to explain the technology of alkaline activation. First of all, I would like to mention, even though it has been previously mentioned, that CO2 is the main cause of global warming. And therefore, the decarbonization process must be tackled from all points of view at the industrial, social, and governmental levels. In our society, we do focus on building, specifically concrete, that is a part of our life structure. We must highlight that even though it has very good usage, it also has a significant environmental impact since it produces a high percentage of CO2 emissions. It also contributes to depleting raw materials and natural resources, and it represents a high energy consumption. Currently, we are consuming globally about 30 billion tons of concrete. This means the exhaustive depletion of cement, which is the basis of concrete. To manufacture cement We consume, or this means the emission of about 0.8 tons of CO2 per 1 ton of cement, which means 7 or 8% of CO2 emissions worldwide. What can we do to reduce this kind of emission? We can focus on manufacturing processes and production processes. For instance, using alternative material. Concerning production systems, they have proven to be quite efficient, so the savings are not going to be highlighted further. Currently, we're using other raw materials to produce cement. This would improve all of these aspects, but we also must take into account, as has been previously said, the limitation of the availability of these raw materials or blending components. This is why we should focus on two aspects. First, using a concrete or cement that is quite specific for a concrete use or application. And we also should take into account using other cements, which isn't based on Portland cement, which is the one that has been currently used more commonly. In a nutshell, we should go from using one universal cement to several types of cement. Several cements like supersulfated cements, or those that are activated in an alkaline manner, alkali activated materials, instead of calcium aluminate based cements. These cements are very attractive. Why? Because they reduce CO2 emissions and energy consumption between 80 and 60% respectively, comparing to Portland cement. They also take fire well and also aggressive attack. In this slide, I have wanted to show how the alkaline activation processes work. This is how we use we use raw materials that are based on aluminosilicate materials. As source of aluminosilicate, we can use blast furnace slag produced in plants and metallurgical, siderurgical plants. There's also coal fly ash created by combusting carbon in several plants. We can also use natural pozzolans or calcined clays or calcinated clays. Concerning alkaline solution, we can use sodium or potassium hydroxide, sodium silicate carbonate, or sulfate. In this table, I wanted to showcase several raw materials that have already been used, and they are activated with different alkaline solutions. To showcase the versatility that all the process has, as you can see, we have several colors here on the table. To highlight the effectivity of all the alkaline activation. In some cases this is desirable, in other cases there's not much reactivity with these materials. And as I previously mentioned, yes, we have reduced 80% of CO2 emissions compared to Portland cement. However, they have some disadvantages, which is the need to use an alkaline solution, which is a drawback. And so we have been working on that aspect recently, and we have been trying to include silicate or carbonate, sulfate directly blended with the raw materials and later on mixed with water to prevent, or avoid the use of alkaline solutions. This is a drawback that could thus be solved. Despite being able to use this alkaline solutions, we're already trading, launching, producing these alkali activated cements. In Eastern Europe, China, Australia, we are increasing the usage already in the European Union. I wanted to show here a few examples in which this kind of technologies has already been used to for pavements, retaining walls, or sewer pipes. The sewer pipes that you can see here are used in airports, etc. Right now, here are two aspects that could be highlighted concerning the technology of alkaline activation. Firstly, we're speaking about waste management and its usage to immobilize radioactive resources. In the last few years, the European community has launched several initiatives to go from the linear economy model to the circular economy model to optimize resource use and minimize or avoid completely generating waste. Traditional building materials need to consume a high quantity of natural resources for its manufacturing, and they also create a high percentage of waste. However, on the good side, they can be used as a drain as well, a sinkhole. These waste can come from building and from other industries. They can be used as raw materials and also as activators. In this case, I wanted to show a few ways got from asphalt filler waste and fluorescent lamp waste. And we used a solution to clean shapers, and all of this was activated at 85 degrees for 20 hours, and thus we got all of these plaques or units that you can see here, and we used it as urban pavement. We have tested them to see their reflection and strength to see whether they could be used as pavement. Here we can see how all of the studied formulas under the regulations established with the formulation 75% asphalt filler waste, 25% fluorescent lamp waste, has reached the highest level of strength. We have tested them several times to determine the liberation of several components and being able to catalog the material as what kind of material would be gotten, whether it's dangerous, inert, etc. This one can be cataloged as inert waste. This is why we are sure that we can use these units as urban pavement. In this other example, we have a project in which, I am in the team of this project, and we are using waste from Iberia and America to build building materials with a low carbon footprint. In this case, the raw material is fly ash and oil well muds. As activators, we are using NaOH and also dissolving rice husk ash in this blend. We blended it, we fired it for 85 degrees for 24 hours, and we have obtained the material that you can see on screen. Later on, with these materials, we have wanted to build pre-prepared concrete to build enclosure for pigs, particularly for pigs. We have selected the most appropriate formula, and we will be testing their durability to see whether they can actually weather the conditions, really. Perhaps in highly elevated areas and exposed to animals, really, and environmental conditions. The other thing I wish to emphasize is the possible application to immobilize radioactive waste. Due to the dismantling of all the Spanish industrial park, it is very important to think about the initial conditioning and also being able to later dispose of all this material. This is very significant. This is a study that has been tackled in our project, which works with radioactive waste here. We want to use ion resins to purify the water in the primary cooling circuit. Once this has been done, they are considered as low and intermediate level waste to be disposed of appropriately. This is why in Spain we are mobilizing several of these projects. Later on, we use different chemical barriers in different layers of Earth. In this project, we wanted to use alkaline activated material to use these resins. In all of these studies, we can see that all of these materials can immobilize a higher content of resins. In the first slide, I wanted to show mechanical resistance of the reference matrix, that is cement, with 7.5% of resin and cement. And you can see how mechanical resistance ends up being higher. I also wanted to show here this graph in which we have included the maximum amount we can immobilize, taking into account a few prerequisites, and we can see that it goes over 10 megapascals as a limited value to immobilize this kind of radioactive waste. Lastly, well, in this last example, here are the results that we are obtaining in our project. In this case, we have focused in the protection of the corrosion of metal containers that contain low-level waste storage. In this case, the radioactive waste that we are immobilizing is material that comes from decontamination of radionuclide contaminated metallic surface. These sludges, as shown here on screen, can be liquid sludges or solid sludges, and so we are assessing what is the most appropriate way of using them to immobilize the highest possible quantity of sludge. In this case, we used this comparing to the cement that we are currently using to immobilize this waste. We saw that in the liquid state, the alkaline activated materials with sodium silicate and cement are those that showcase most resistance, and these are the ones that can be used. And concerning the solid state, we used a high percentage of solids. And right now we are testing 5% because they did not reach the 10 megapascals that were required to use them. And as I said, once we select the most appropriate matrix or material and the kind of sludge to be confined and controlled, we will run electrochemical tests to find out the corrosion that all metallic containers can go through when in contact with the sludges. And we'll use different protection methods, such as stainless steel, among others. You can see that several materials have been manufactured to be used, for instance, as urban pavement. They can be used in pre-manufactured concrete to build enclosures for animals, and we are also running investigations concerning the immobilization of radioactive waste in these materials. So of course we can use these materials to create bricks. Well, of course. And next, Dr. Monica Vicen will talk about the development of non-fired building materials coming from waste. Thank you very much for your attention.
Muchas gracias, María, por enseñarnos.
Thank you so much, Maria, for showcasing all the amazing possibilities that the technology holds and how we can use them to curb CO2 emissions. Next, Dr. Monica Vicent will be speaking. She also works with me in the Institute for Ceramic Technology. She is the main researcher of our project. And in 15 minutes, she will give a summary of the last 2.5 years.
3.5, me dicen.
3 years and a half, to be more specific.
A ver si me aclaro cómo se pasa. Así. Vale, lo tengo claro. Muy bien. Buenos días a todos.
Good morning. I am Monica Vicent. I work in the Ceramic Technology Institute in Castellón. And I'm going to introduce the Life HYPOBRICK project we've been speaking this morning, and we will try to describe it, and so that you can understand what we've tried to do, what we have demonstrated, and how happy we are with the results. So what's the goal for this? Once we've reached this point, Ana Mezquita and Antonio have been telling about the goal for Europe for the year 2050. So the goal is to reach zero net greenhouse gas emissions. How are we going to reach that objective? In the ceramic sector, we know that the firing stage, as Antonio has explained, is between the 55 and 80% of the emissions of CO2 of the ceramic process. So what are we doing in the Institute? We are studying low-impact alternatives. We are doing this through the hypocarbonic project. We have already built a hypocarbonic pellets plant in our institute's facilities, and we have published a guide or a roadmap on how are we going to work, the different alternatives, and when we send you this presentation, you will be able to download it. We are also studying, as Antonio has already mentioned, the possibility of changing to electric process. We are studying this in the energetic project. Another alternative would be the use of other fuels like biogas, like hydrogen, that's being studied and researched in the Hydrocare project, and others that come up along the way. And when you download the guide, you will better understand the situation where we are at. Beyond all of this, as Anna said, the emissions by 2050 should be net, should be zero. That's what Europe expects it means we can emit, we have some emissions, but we can capture them or absorb them, and that's something we are studying in the Capturo 2 project. And we are also studying different formulations of the support and the coatings with the objective of reducing CO2 emissions. This is something we've been studying in the Institute, and we are having another solution, which is the Live HYPOBRICK project. So in this project, we are completely going to delete this stage of firing, and it's going to be substituted by an alternative process in a temperature which is under 100 Celsius degrees. So we have an energetic consumption which is less, we reduce the CO2 emissions, and in this case we can use waste instead of using raw materials as a starting materials. So we contribute to all of the European policies, we maximize the recycling, we have a cradle-to-cradle system, we are also reducing the energy consumption, and we reduce the volatile emissions, acid emissions that happen in the firing process. How do we do this? If we do the scheme on how we do today the ceramic bricks, we start with raw materials, we do the dosification and mixing, the milling, the kneading, the extrusion, drying and firing, and then we get the ceramic material. It can be blocks, it can be bricks, or flat ceramics. So the firing process is between 850 or 1200, depending if it's clinker or not. And so we erase completely that stage. So how do we do it? We will start, we have as starting materials waste materials instead of raw materials. They will undergo the milling process, then the dosification and mixing. We knead them not with water but with an alkaline activator. We shape them, we cure them at a very low temperature. It's under 100 degrees compared to the 1000 of the curing process, and then we obtain this alkali activated materials with similar features to the ceramic materials. So what wastes have we used in the project? In our project we have used, this is just a summary of the ones we have been using, but we've used fly ash from coal power plants. It is true that now in Spain there's a trend of not using any more coal, but for example, this is not happening in Germany. This is a project with Spanish and German colleagues. We have also used fly ash from different thermal plants, glass from different industries, for example, glass from cathode ray tubes. It is important to highlight this because this glass today goes to waste because of the high number of toxic compounds it has on it. We had also used solar panel glass. We have also used non-color ceramic scraps from the industry, the manufacturing industry, colored ceramic scraps that maybe come from rubble, from different buildings. We have used the mixed mineral rubbles with concrete, with cement. We have used some waste from some sands that came from clay waste, and in the last photo you can see that we have tried to use plastics that come from electrical and electronic equipments. Now I'm going to show the main results we've obtained. For you to see that we've we've made it. On the left, you can see the slabs we have obtained in the Spanish, and in the right, the slabs from the from German. So we have very good numbers of the bulk density in Spain and in Germany, even better the ones from Germany, but both are good and they are complying with the requirements. We also have some slabs that resist to thaw. We have been able to reduce and do not have any efflorescence that can happen if we don't dosify the alkaline activators. And there's been no leachability due to the lead that there was in their glass. At an industrial scale, as you can see on the left, the Spanish study, we have fabricated in an industrial way bricks which have been alkaline activated, and in the right, in the case of the German study, we have fabricated alkali activated blocks. In this case, I show the main results. So we have been able to reach the characterizing values of the similar products, the ceramic products, but in other cases we have obtained better features. If you have any doubts later in the Q&A, we can go to more specific data. So with these bricks and blocks, we have built two demonstrating plants, one in Spain, another one in Germany. So we have, as Chris said, in the live projects are projects to showcast the results, and we have been able to demonstrate the results building these test buildings. And from all of the results we have obtained, it is important to highlight the reduction of the CO2 emissions we have achieved. We were always speaking about an 80, even 90%, because we always think that when we remove the firing process, we are going to remove all of the emissions. But we also have to take in account the CO2 of the production of the alkaline activators. So taking into account the CO2 of the production of the alkaline activators, we have been able to reduce 68% of the CO2 in the Spanish case and 60% in the German case. To wrap up, I would like to introduce the consortium, which is formed by Spanish and German partners. It started in 2019, and now you are going to see why Javier said 2.5 years, because there was the pandemic there and we didn't know if we were going to continue or not. But it started in October 2019. And yesterday we had the last session of the project, and tomorrow it's the end of the project. As partners, we are the coordinators from the institute, and as participants, we have Ladrillos Mora, which is a brick company in Illescas, Toledo, that has demonstrated, it was on the left, always the left of the presentation, it has demonstrated the technology producing alkaline activated bricks in an industrial way. In this consortium we also have RCS company. They are from Valencia. They manage waste, and they have helped us in all of the information spreading tasks. We also have the Slagman company from Germany. It was on the right side of the presentation. it has produced the alkaline activated blocks, and also the Nuremberg University that has helped in all of the research tasks, technology tasks to reach these demonstrating buildings. It is very interesting that I show this picture because on the up left there was the kickoff meeting. It was in October 2019. And from there we didn't do any other on-site presentation. All of them were via internet meetings until October 2021. For the first time in 2 years, with wearing masks. So it was tough to work in this pandemic era. Each of us in a different place, everything online. We have had a tough time, but we have get good results, so we're happy. Thank you so much for your attention. You can see my contact details, the webpage of the project. We will send you the presentations, so if you have any question, anything. And just to finish, I would like to underline that this project, it's framed among 4 SDGs, the 7, 9, 11, and 13. Thank you so much. Thank you, Monica, for being so happy to introduce this project. We are on time, which is quite surprising. The last speaker before the coffee break, it's one of the industrial partners of the project. It is Diego García Fojeda from Ladrillos Mora, pretty close to Madrid, in Illescas, Toledo. If you go to the enterprise, you can see that wall with bricks, more than 15,000 bricks. It's not that 20, 30 bricks, it's much more. You can see it. And Diego is going to give their vision on the adaptation of the ceramic manufacturing system towards this zero emissions we are being forced to reach by the European Union.
Buenos días, muchas gracias a todos.
Good morning. Thank you so much for being here. I represent Ladrillos Mora, the company. We're a family concern. Right now in its 4th generation. It was born in the 50s. From 2006, we have built face bricks. And from 2011, we started exporting. And we mostly sell in all of the countries in the world. In such milestones such as New York, Paris, Brussels, Sydney, Dublin, Auckland, New Zealand, Seoul, Toronto. We are the official supplier of McDonald's and Starbucks in the United States. We are strongly aware of the environment. And in the last 10 years, we have tried to reduce the energy consumption of our company, right? Because it uses a lot of electricity and thermal energy. In these last few years, we changed our kilns so we can preheat the air that the heaters use to reduce by 5% the thermal consumption of the entire kiln. We also rebuilt a significant part of the place where bricks are produced, and kiln cars by 5%. We have lowered thermal consumption by 5%. The mass that's being fired, it's half of the brick we're going to sell, and the other half is supported by the kiln cars. We also substituted natural gas by biomass here in the milling process. This was last year. And 20% of electrical consumption was lowered with an installation of 1.5 kilowatts panels.
This is the third project of development that we participate in. The Life Clay Glass is also another project in which we participate. We gave a second life to a product, to clay glass used in old screens, on old TV screens, which has a lot of lead. And so we wanted to reduce the temperature, maximum firing temperature. We did this between 2014 and 2017. Our partners were the University of Thessalonica in Greece and other companies, and the total budget reached almost 2 million euros. All of these changes, 5% here, 10% there. With all of this, it's hard to imagine how you will actually reach zero emission by 2050. At the end of the day, if we truly think about it and you don't absolutely disrupt the process of manufacturing, there would be no way to reduce the pollution that we actually create. This is why we're in the Life HYPOBRICK project. In the Life HYPOBRICK project, we eliminated the main source of pollution, which is firing. We substituted the process, but a totally alternative one that is able to reuse a part of the facilities that currently exist. And it is also capable of using as a base the demolition waste. And currently, only 25% is being used nowadays. As we explained, it is a consortium with Germany. The budget is slightly lower, 1.6 million euros, and the period from 2019 to 2023. Our product is absolutely equivalent to FaceBrick. It has the highest rating in terms of electricity use. It complies with all requirements. We actually built a 19 square meter wall at the entrance of our company. Well, to show it and also to analyze its durability. Everyone was really happy with the results. The next few steps within this project is building a prototype. Well, we have actually built a prototype to produce all the pieces at a small scale. And next we will study how to scale this to an industrial level. Our target in this project was to design a prototype, since the way in which we manufacture bricks is quite different than the traditional one, and trying to integrate 100% of the base with recycled material. And especially integrating the prototype to the existing facilities. It makes no sense to have a built facility and for it to be there and not have a life within this project, to not be used within all this process. Concerning sustainability, it is true that the Spanish production is about 30 million tons per year, and the waste generated from the demolition is 40 million tons per year. So only 25% is used nowadays. There's more than enough raw material, therefore, to be able to continue in this process to manufacture all the bricks that the market needs. In our case, we fire at very high temperature, 1200 degrees. So taking away the firing stage represents a reduction in thermal consumption by 95%. The product that we have gotten is very similar to a traditional brick, and this is thanks to our current facilities. Here you can see the slide of the normal production process. And in the new one, we have different stages without the firing stage. We have been able to adapt the milling facility for the production. We were able to reuse the dryer as a chamber for curing. And we have built a prototype that is able to manufacture this kind of brick. I'm gonna try and put on a video. I'm not sure if it's working. Here, there's a kind of vertical extrusion that does not stop because this raw material gets hard very fast. You can see here the milling, and we apply pressure according to the time that all the material is under the helix. After every single manufacturing, the machine must be clean. And once it is absolutely full, then we put the material in the chamber for the rest of the process, obtaining a new product, which aesthetically here, the color depends on the kind of waste used. We have used some black brick waste, and so the bricks here would be black in that case. And so we built a wall of 19 square meters, which complied with its role. Concerning the LIFE project, which is the second one that we conduct, I would like to highlight that differently than other projects, it is possible to participate in proposals, industrial proposals, that validate at the lab scale and research scale to take it to the industrial world. This is very hard. Making it viable is very different than anything that we can obtain in a lab. As Chris said yesterday, the LIFE project cooperates in the risk that it represents, because in other kinds of project, you need to be absolutely sure that what you're doing is going to work. Because at the end, you need to give back that loan. So already from the company point of view, this is a financing for something that you can't yet tackle, but you know that will work. And so it's a huge risk. But in this kind of project, then yes, this kind of project does fit. Of course, we can build prototypes as well. In other kinds of financing, one can only use this cushioning. You can only include the hours in which the machine has participated in the project. So this is quite ridiculous, unless the machine will be used in the future, and that is guaranteed. And it has high financing percentage. In this case, it's 50%. Last but not least, after all the session, I would like to bring up a thought, which is, even though, as Antonio has said, we are doing our homework, we're forced to do our homework in part, but I guess that's good. I believe that from the Commission, and this is personal, we forget two pillars here in the equation. One is imports, because we are importing pollution from abroad. So when we observe the 30 most contaminated or polluted cities in the world, they're all in China, India, Pakistan, or Bangladesh. I believe 2 of them are there. And we're not doing anything. The product coming from outside shouldn't comply with any of the requirements that are demanded here. So if I have a certain number of emissions per year and I manufacture a brick that complies, this cannot compare to a product that comes from abroad. On the one hand. On the other hand, there is sustainability from the point of view of reusing, because we manufacture a product that will last forever. That can't be measured. What are the emissions that won't be reused, for instance? Not something that is measured. I mean, how much does a brick last? 1,000 years? And we're living in a kind of society in which we promote change all the time. Doing things again. Right now we're going through this with electric cars. Many people are forced to buy a new car to be able to enter the city of Madrid. They have a perfectly well-functioning car, but 60% of the emissions of cars are emitted once the car is manufactured here. We have moderated our emissions throughout the year, but 100 years ago, 80% of works in Europe were in industries or in the fields, really. We pollute less, because we are producing things abroad and importing them. This is why in the graphs you see pollution, higher pollution in China and less pollution here. And so we must tackle these 2 topics so that everything may fit together and we are able to so that the photograph that Chris showed about a parent giving money to his kid does not become a reality. We need to be more sustainable in the future. Thank you very much. Thank you very much, Diego, for telling us of your experience in the LIFE project, and especially for your last thoughts at the end that I'm sure we all share. We have a coffee break right now, which is upstairs. We have 15 minutes. Let's go upstairs and take a break.
Bien, buenos días de nuevo.
Good morning once again. After the coffee break, we are back to finish with the last two presentations. We have the two German partners of the project. The first presentation, it's with Jens Gedum. He comes to represent Schlagmann Porton Enterprise from Germany, and he's going to speak about building blocks with high recycling waste content for masonry construction.
Okay, thank you. Yeah, buenos dias. That's all what I can say in Spanish, I'm sorry. My name is Jens Gedun. I'm coming from Schlagmann Porton. This is a brick producer in South Germany. I'm doing this job 14 years now, and I guess I can show you something. Is it not going? This one. Okay. Yeah, at first, to present you some details of Schlagmann. In brief, what you see here, is it the pointer? Yeah. What you see here is our cash cows, our outer wall bricks, what we produce in Germany. This is for the monolithic wall construction. This is just this single brick in its width, and you make the wall out of it. And then you have just a render for the inside and the render for the outside. And this is the usual brickwork what you use for residential housing, at least in South Germany. Yeah, usually in the north or middle, we have again this facing bricks, what you have seen by Moras is also existing. But then it is a double leaf masonry, so two walls. And usually, or sadly, then the inner wall is often not made by this kind of brick. Yeah, what to say? And we have a share with the Wienerberger Group for 50%, but we feel more like a family-driven company. And we have about 400 employees over all locations and have a turnover over 100 millions. And we have also a foundation looking, for example, for new builders or the apprenticeship builders, and they are awarded by us when they are very good. What you see here is our headquarters in Saarland, where I also located and where I'm doing my R&D stuff. In the back you see already here our clay pit in the back. So we extract our main clay deposits directly here from the clay pit nearby. And then we have two plants here on the side, 1 and 2. And what you have seen in the beginning is this brick for outer wall with very strong insulation properties. And this is enhanced by volcanic rock, which is perlite, expanded perlite. And so we combine, for example, for this high insulation, this insulating material inside the big voids of our bricks. Yeah, we are here in South Germany. Our headquarters is really close to the Austrian border, and our other plants are, yeah, for example, nearby Munich or even the north. We have not only outer wall bricks and inner wall bricks, we have also a quite large accessory program. What you can see here, so we produce overall 300 different kinds of these backing bricks, we call it as well. And now let's come to the product development, what we did in the live HYPOBRICK project. First of all, I have to see from the market perspective where we are here, that is not much known for geopolymers on the right-hand side. What you see, I call it the sodium world, in spite of the existing calcium world, which is clearly driven by normal OPC cement, gypsum or chalk or lime, and also for bricks. Water glass is quite known for painting, for example, but geopolymers are, from my point of view, at least for wall construction in Central Europe, not known or not existing. So what we concentrated on for the product development was here for a special block, which is also in our accessory program, what we use here for dividing flats. This is a specialty. It's a so-called desk sheeting brick, I can call it, so that you build it up and fill it later on with the concrete. And then you have a real high sound reduction to dividing the apartments, for example. This is just mortared with a thin bed mortar. This is our usual business, to have grinded bricks which are only mortared with a thin bed mortar of 1 millimeter in thickness. Here a clear picture what we do usually. Here's a large industrial production for clay bricks by extrusion. On the left hand side the whole apparatus clearly known, and we produce usually an endless strand which is then cutted by a wire. For this we need plasticity, that's clear. That's the reason why you use clays, like for pottery, for example. So when we then started to extrude pastes, geopolymeric paste, we see that the lack in plasticity and stiffness, that we need both, of course, for the green brick or green strand, fresh extruded, that it is really hard work, a hard task and a hard challenge to extrude at least a middle scale. And for us it was a clear intention to see that it's so easy not possible, because if it is not working in a middle scale extrusion, what we do usually to make new clay formulations, which is also usually not easy to extrude, and to have enough plasticity, for example, and the stiffness, we see that we cannot go on industrial scale. So for that we shifted to molding our geopolymer paste, maybe then more a slurry to add some water and fill these molds. And this is the original size of the geopolymer brick to mimic the exact geometry, at least from the outer walls, the size of the classical clay-based brick. And what I have here with me is my baby block. So what it is better than to touch a new prototype. Of course, this is not the original size, but it is a 1:3 ratio all about, and I can give it to you to touch it. Is it a little bit acrylic at the surface? I guess it is okay for you. So please come in touch with. You see that it is possible in general. It is also grinded to have this clear planarity and to use it in the same way as usual by a 1 millimeter thin bed mortar, for example. Or also PU glue is known. Here the big challenge was the shrinkage. If we use this slurry with maybe too much water, it's clear that the shrinkage is existing, like also for concrete slurries or whatever. But here you can see clearly on the picture it caused cracks, especially at the joints here from the cross and the lengthwise webs, and therefore we have to overcome this problem. 2% shrinkage was it as at first, and that was really too much. You see here the damaged, not demonstrators is not the right explanation, I guess, but nevertheless we had to work on the formulation. And later on we tried out to use some fibers, for example, to have more adhesion, and to look also on a glue, for example, and to see later on that, for example, fly ash is a perfect filler to minimize the shrinkage. And therefore we had success that we have in the end no shrinkage, or not nearly not measurable. And that's also the reason or disadvantage of this is, of course, the demolding, yeah? Because it is really fixed in and not easy to demold, at least the outer walls of this mold. But nevertheless, we could succeed here. It was quite a lot of manual work, what you see, to prepare the paste, the materials, the conditioning of the raw materials. And afterwards, we could grind it, what you see here on the left-hand side in this picture. And then it is a real big block. Also not easy to produce as a clay brick, yeah, because it has big voids, and it's not easy. To summarize, and due to the fact that we want to mimic the clay-based brick, we saw here that we have a little bit higher strengths, about 20% better. Here on the left-hand side, the compressive strengths, and on the right-hand side, a special method to get in a view on the impact resistance. After that, we made an upscaling with our biggest mixing machine. What you can see here is an intensive mixing machine by the company Eirich, well known maybe for some of you. On the left, you see here the raw materials here, even with some fibers in white. And on the right-hand side, you see also the viscosity that we need. We need not a paste for the molding, we need more lower viscosity. And you see maybe the drops falling down again from the stirrer back into the bottom here. Yeah, with a lot of handcraft and with the use of some lab assistants, I have to say, we were able to produce at least round about of 50 blocks. And what you see here in the end, or what you have already seen from Monica, is here our clear wall. Of course, with some 50 shades of gray, I guess, here, but we are not so interested in colors. You see here the block, maybe what is walking around here is more red due to the high content of brick waste, red brick waste. And if you add more fly ash, it is more gray. Yes, here again the wall in a closer perspective. And yeah, it was clear that it was really nice in geometry. Yeah? You can grind it smoothly to have real clear planarity. And here you can build up in the typical way what we do usually. To summarize, we were able to use 70 to 85% recycled waste material calculated on the whole product. If I see here the presentation, it is 100% if we do not take the alkali activator into account. Yeah, what I already said, the geopolymer block was better in strength compared to the conventional one, and we could at least establish the batch process for us to produce 6 blocks immediately. Next, what we should do is some destructive tests. Maybe some of you know the RILM, small walls, what you can use to have an idea what is the compressive strength of the small wall, for example. Or durability tests in combination with the compression to mimic the real story pillar, for example, to be more or to be closer in reality. What else? The application tests here, non-destructive is clear. So what maybe you have seen before, the addition of cement, this should be tested, of course, in real. And last but not least, a very important point are the cost efficiency for new formulations, what we should focus on due to the fact that the alkali activation is quite costly. So we go again to some recipes and look to reduce the alkalinity and as well fly ash. At least fly ash is for us quite expensive. In Germany, in Poland it's different. In Spain it's difficult to get it. So we have to take into account the special situation in each country. Okay, then maybe I have some time left to show you some other decarbonization strategies in our heavy clay industry, at least for us at Schlagmann. So we are using, well, we have already some EPDs, and we have a when I compare the cradle-to-gate approach with a global warming potential of 200 kilograms CO2 equivalents per ton, that's where we are. And at least for a new funded project, we are looking for a special lighter brick, or kind of brick, or brick panel, with a vision to reduce CO2 at least for 95%. I think it is clear that it is possible, maybe not for all bricks directly, but at least for this vision, we have, of course, to detect the carbon source. What I maybe show you here in this graph, due to the energy management and due to the fact that we are really affected by the EU allowances or the ETS trading system, it's clear where we are. So we have process emissions and energy emissions. Energy emissions means that it's coming from burning natural gas, and the process emissions are coming from limestone and all the other ingredients we have from carbon by nature or even by other raw materials we add, like paper sludge, for example, which are also containing calcium carbonate. It's clear that if we switch the energy, or no, if we switch from natural gas to electricity, which is driven by renewable energies, that we can come down with the product emissions, let's say. On the other hand, we are looking for new clay deposits around our premises to avoid limestone. We had in former times a project for this, and I guess we are able to reduce also this. And therefore, I think it is in general possible. We have to look on our two main processes, the drying and the firing. And for this, or to substitute natural gas, it could be possible in the future to use microwave technology. Here you see our pilot machine, let's say, to be able to dry and to fire a block of 500 to 500 millimeters. What you can see here is the apparatus for the drying state, and on the right-hand side, what is it? An IR view into it, just for drying. I was not aware of that you can fire a brick by microwave, but it seems to be possible. This is but really the future, and we are looking on this in the next funded project. The benefit would be, if it is efficient, to have a clear electrical process and to get rid of natural gas. Here, for example, a picture from the colleagues from Wienerberger who had a project with an industrial heat pump to reduce the emissions at drying the bricks. I think it was successful. Also, the heat pump is not existing any longer. It was demolished by driving it for some years. So, but nevertheless, the idea is quite interesting, and that's what we also want to use in the future, that we decouple the dryer and the kiln in order to use the heat pump. And there are other kiln technologies at least existing. So this is on one hand the modification of gas nozzles as a prerequisite, and the use of syngas or hydrogen, or what we are focused on now is the wood gasifier delivering clean syngas. The problem of all these, the challenge here are the huge investigations what are needed to realize such big equipment. And therefore there's also need for funding, I think. But it's existing. To say that it is not only a show, that so we are really working on that, I can give you at least here the figures. For example, to enhance the photovoltaics on roofing of the storage place. Maybe you remember my big picture. We have a lot of storage place, but it is not efficiently used in that way that we could install, for example, on top of our pallets or brick stapling photovoltaics. And if we take it to account here, or to sum up everything, it is at least 6 million kilowatt hours per year what we could produce by this method. And on the other hand, the wood gasifier, it's also a huge project where we are in Bavaria, we have a lot of forests. There's also a lot of tree wastes. Not easy to get it, but nevertheless, you could produce about 10 million kilowatt hours per year with this method to produce syngas, and when you adapt the nozzles, you can use it for burning. And this is, I guess we get now the funding, or the okay, by the authorities, so that we would like to realize it. Another subject would be a wind turbine or a windmill, which is sadly a little bit complicated in Bavaria to get a permission, because it's not very popular, to be honest. Yeah, that's it from my side. Thank you for your attention, and hope to have a discussion.
Thank you very much, Jens, for your presentation and the company standpoint of Germany. And the last speaker is the Professor Wolfgang Kramer. He comes from Nuremberg University, from the THN Center, and he's going to speak about the status of geopolymer research in building materials.
Ladies and gentlemen, I welcome you to my presentation. First, I have to say sorry because my English is not so good. I look here. I will say something about the fundamentals of geopolymers, previous and future research work at the Nuremberg University of Technology, and my name is Kretschmer, and I am from the Faculty of Material Science at our University of Applied Science. The fields of my work you see here. I work with energy-efficient building materials and insulating materials. You see here, You see here highly insulating building materials. As example, thermal insulating bricks, mortar, thin bit mortar, plaster mortar, geopolymers. I think since 12 years I work with this material. Insulating materials, as example, nanofibers and aerogels. Here you see aerogels. We can prepare it. And here we have the nanofibers. It's material from polystyrene. And we bring these two things together so that we have aerogels, stabilized aerogels. Construction material, facades, energy efficient facades, recycling building materials from cradle to cradle. We work this in HYPOBRICK. Thermal insulating coatings, easy to clean coatings, and finite element simulations about thermal and sound insulation. And then we do a laboratory test and construction projects. You see this here. It's a project called HYPOBRICK with the best thermal insulation of the world with bricks. I say something about the geopolymer reaction. Here you see the cross-reaction equation, and you need a material which contains aluminum oxide and silicate. And then you have to do the alkali activation, so you can generate silicate and aluminate monomers. Here you see the reaction. You have a polycondensation here with from silicate monomer and aluminate monomer, so you prepare water, and you have here the dimer, and if you have here OH groups, so you can the polycondensation go on in all three directions. Here you see it with geometry. It's a tetrahedral structure from silicate monomer and aluminate monomer. And this is the product we create. What did we use in our project? We use a fly ash, ground granulated blast furnace slag, metakaolin. We started with metakaolin, burnt from kaolin. You see here the reaction. It runs about 550 degrees, but then we go to 700, 750, and 800 degrees so that we can create metakaolin. We use fly ash, metakaolin, and mixed rubble and concrete rubble. And here you see the first step. I said it before. You have alkali activation of aluminate and alkali activation of silicate, so you create this monomer. And so you can have in the next step the 3D geopolymer network, and you see here an example for high-strength geopolymer. We can prepare this with a compressive strength to 120 megapascal. Here it is Newton per square meter. It's megapascal. It's very high. And with the same reaction, with other chemicals, you can create a geopolymer form. You see here the bubbles. And here's the compressive strength is only 2 megapascal. Both you can bring all things between that, form or high strength. Here you see reactions we done. Here we have the compressive strength, and here we use 3 sorts of kaolin, and we burned it to metakaolin with 700, 750, 800 degrees with 3 sorts. And here you see the compressive strength. You go up with the temperature, so you have a better compressive strength. You see this here. And here you see the thermic insulation. We create a form. Here you see the glue, the geomer glue, and we prepare it, and we put in this material H2O2 or aluminum powder, and so we can create hydrogen, and the geopolymer glue in 15 minutes grows up, and you can have a form with here this is the shape with pores in different shapes. Here you see the geopolymer form in different shapes, And you have here, with the form, the compressive strength about 2 megapascal and the thermal conductivity about 0.065 watt per meter and Kelvin. Here, structures of the pores. We integrated the geopolymer glue in bricks. Here you see a hollow brick, and here we fulfill the geopolymer glue in this hollow brick, and then you have to wait 2 hours as example, so you see it there. The hollow is filled with geopolymer, and here the structure, you see porous material, and we can give mixed rubble or concrete rubble in this geopolymer form, and we fulfill this in the bricks. Here you have the thermal insulation, the thermal conductivity from the hollow brick, 0.22 watt per meter in Kelvin, and if you fulfill it and you make a new measurement, you see it is going down to 0.12 watt per meter in Kelvin. So you can have an improvement of the thermal insulation about 45.6%. This picture is very old. You see it here in the year 2015. I have bring this at the trade show Keramtech in Munich, and you see this here. I put the cuttings, the geopolymer cuttings, I fill it in the brick, and here you see the high strength geopolymers, and here's the geopolymer form, and here we write the year 2015. No one from the brick industry are looking at that at that time, but at the last Keramtech last year, all brick industry was there and looked at this. Other examples, we create geopolymer form with fly ash, with diatomaceous earth, and here you see the fly ash, a RAM picture from the fly ash, and fly ash in geopolymer. Here you see the fly ash, and here you have the fly ash, and the material here is fly ash, and at the outside here you have the geopolymer. Some examples of the compressive strength and the bending tensile strength. The compressive strength here you see at this page, and here we have done mixtures, 100% fly ash, and then we can down with the fly ash 75%, 50%, and so on, 0%, but 100% metakaolin, and you see the compressive strength is going down, and the bending tensile strength did the same. And with this mixture, we use fly ash and slag sand. You see the compressive strength is growing up, and the bending tensile strength is growing up too. We have here the same mixtures. Last slides. What can we do with geopolymers? We have seen today some samples, and I have here samples too. You can prepare high-strength building materials with geopolymers. Here you see a brick example. You can do substitution products for classical building materials. And the material is cold hardening. You did not need energy as gas or oil to produce it, and you did not have the emission of CO2. You can prepare thermal insulating building materials. You can prepare filling materials for sound and impact sound insulation. You can prepare fire protection boards. You see this, it's called chamotte over here, fire protect boards, insulating materials and refractory products. You see here a wood-fired oven, and here you have chamotte in the oven. And this is our next project with geopolymers. We want to substitute chamotte with geopolymers for this oven. Last slide. What can we do with geopolymers? What have we done with construction waste? Here we can use the construction waste to geopolymers, and you have a new building material. And in this project, we want to prepare geopolymers with natural fibers. So many thanks for your attention.
Muchas gracias, Profan, especialmente.
Thank you very much, Professor, particularly for your effort in speaking in English. We lack a speaker at the last minute, so we have a few minutes for questions for people that are here with us today, as well as those that are watching us online through the chat.
Sí, hay una pregunta de Elena.
There's a question from Elena.
Hola, buenos días.
Good morning. Firstly, congratulations for this session and for such an interesting project. I have a question for Diego. I could have used the coffee break to ask him, but I would like him to delve into more details. What's the percentage of clay that is being used to manufacture these face bricks? What the percentage of geopolymers? Concerning costs as well, I believe that it's important to speak about manufacturing costs. That was the question. Thank you very much. As I was saying, the cost depends on the alkaline solution used. Costs has increased by 20% in the last 4 years. We need to see what happens after the energy conditions and the energy facts become more stabilized. And it also has to do with what we do with face bricks, because we may forget or not use the firing process and see what happens. Also, as for the clay content, which is a paramount material in construction, it's 90% without taking into account the alkaline solution. So it's 90%, 92% construction waste, 8% glass waste, and over that 30% of alkaline solution. Have I answered your question? Did I forget anything? No?
¿Alguna pregunta más?
Any other questions?
Sí, hay una pregunta al fondo.
Yes, to the back there, someone has a question.
Muchas gracias.
Thank you very much.
I want to ask Dr. Jens about the kind of geopolymer that he used to manufacture bricks or brick blocks. Cannot translate without a microphone, please.
Maybe I did not focus on this. On one hand, we, of course, as brick producers, we want to reuse our own wastes. At least at first. We have also already a recycling system to get back. It's so-called the 1 cubic meter brick waste. What happens in new constructions for single-family housing, for example? Yeah, it's a 1 cubic meter what you get, and so our offer for our clients is, because they getting our bricks by trucks, and they they bring back this container with the brick waste. It would be the first source of us. Up to now, it is, of course, a downcycling for roofing, for tennis places and whatever, what we can collect, sorting, and reuse for this downcycling subjects. Nevertheless, of course, with geopolymer, we make upcycling. And for this, we are able to, let's see, the formulations are a little bit distinct concerning the shrinkage. I guess we are able to use 100% brick waste conditioned in the corn size. I guess this is the key to mimic shrinkage. Due to the fact that we used also fly ash, so it was the gray, what you see in the pictures was 50 to 50, brick dust and fly ash. But the fly ash is quite costly and not easy available, and we are in competition to the cement industry, like it's a classical picture here. So we have to, if we really want to come up to the market, we have to do it without fly ash, is my impression. And to reduce costs, and even now, to see, if I see the really high pricing of sodium hydroxide, at least our last offers for Germany, €3 per kilogram, it's hard to handle this pricing due to the fact that usually you have this price arrangements for a ton of clay, for a ton and not for a kilogram. So this is at the moment where we have to focus on, I think. Yeah? You're welcome.
Bien, ¿hay alguna pregunta más?
Is there any other question? Any other question in the chat? Well, if there's no more questions, I would like to finish today's session telling you a little bit the feelings I've got and gathering a bit the ideas we have transmitted, which are very interesting. First topic is towards the industrial world. Christophe has said that we should leverage the LIFE tool to take to the market the projects which entail some risks, as Diego said, and that partially are financed by the European Union, and that are projects always focused on improving the environmental quality of the planet we're living at, because we only have one. I would also like to comment, because we have seen this in several presentations, that the ceramic sector has been complying with all of the requirements of CO2 emissions given by the European Union, improving the mixtures, changing machinery. And from ITC, we think we have reached a limit. We cannot improve more than we have already improved, which is a lot. And this entails that it's going to be very difficult to reach these new objectives for the year 30 and year 50. It's going to be difficult. We want to maintain the competitiveness of our enterprises. This is very important because the ceramic industry has moved from the more family sector to be more controlled by industry and investment funds. They have big installations in Europe, but also abroad, overseas, and at least us in the area of Castellón, we are seeing that these great groups are investing outside of Europe instead of in Europe, and this means that there's people who end up without a job, and this affects the unemployment numbers, and this is a problem we should face. I also like to say that ceramic, it's a long-lasting product. I don't know if it lasts 100 years, like Diego said, but in a building, ceramic can last 25, 50, well, even 100 years. It is a product that we produce with these thermal treatments. There's CO2 emissions, which are pretty high. But if instead of looking at the CO2 emissions per ton of product, we measure it by ton and year of use of the same product, we realize that the CO2 emissions of the ceramic products are very low. Lower than other products that have less emissions. We should take a look at analysis of life cycle. And when we face ceramic products with the competing products like wood or vinyl, we realize that ceramic products have less carbon footprint, and it is something we should always value. And finally, I want to thank the European Commission for the space, the speakers, the audience, and especially the 3 enterprises that have participated in the project. It's not easy to have enterprises participating in this kind of projects, which are risky, because for them it's not R&D, it's a more difficult thing. So I wanted to say out loud, we're thankful for the Institute of Ceramics as a partner of this project. It's Cerámicas Mora, RCS, and the German company. Thank you.